Whenever you look up at the night sky, it just feels overwhelmingly vast, right? I mean, we're talking about billions of stars and literally trillions of planets out there. By all of our math, the universe should be absolutely crowded with life. But, well, when we actually listen, we hear nothing. Total silence. So why is the universe seemingly so empty? To help solve this ultimate cosmic mystery, we're going to look at things through a groundbreaking new scientific lens.
Okay, so here is our exact roadmap for this explainer. We'll start with the Great Cosmic Silence, then introduce the Triune Harmonic Dynamics framework. After that, we'll apply it to the visibility filter hypothesis, dive into Phase 3 informational integration, look at some validation and falsification rules, and finally explore our very own silent future.
Let's dive right into Section 1, the Great Cosmic Silence. This whole existing problem is famously known as the Fermi Paradox. And the question is beautifully simple. If the universe is so vast, where is everybody? NASA has already confirmed thousands of planets, and we know the basic building blocks for life are literally everywhere. Yet there is this massive, glaring contradiction between what we fully expect to find out there and what we actually see.
See, for decades, we've assumed that an advanced alien civilization would be, well, incredibly loud. We expected to find a noisy, booming galaxy just full of stray radio waves, giant megastructures harvesting star energy, and lots of space junk. But our actual observation? Absolute silence. We have zero confirmed evidence of extraterrestrials. So why exactly is the sky so quiet?
That brings us to Section 2, Triune Harmonic Dynamics, or THD. To really crack this case, we're shifting away from traditional astronomy and bringing in a revolutionary hypothesis called Triune Harmonic Dynamics. This is a universal equation and a foundational pattern behind energy, matter, and mind. It was developed by researcher, inventor, and author Kevin L. Brown. And what's so brilliant about Brown's work is how it unifies physics, evolution, and complex systems into a single, predictable rhythm.
So Brown breaks down this complex mathematical rhythm into 3 super easy, universal steps that everything in the universe has to go through. Step 1 is form. That's when things just emerge and start building. Step 2 is tension. This is a noisy, highly wasteful period of growth and friction. It's kind of like a messy teenager phase. And step 3 is integration. That's when the system finally figures things out, becoming highly efficient and perfectly balanced. And here's the kicker. This applies to everything from tiny atoms all the way up to entire alien civilizations.
Let's move on to Section 3, the visibility filter hypothesis.
Okay, let's actually map the early phases of a civilization using the THD framework. In the base phase, which is Step 1, you basically have a planet-bound early biological society that's just figuring out simple tools. But eventually they hit the pressure phase, Step 2. Here, they expand rapidly, they burn massive amounts of energy, they make a ton of noise, and they leak all these radio waves into space. This is their loud, messy phase.
Now, here is the absolute core twist of this entire explainer. Truly advanced civilizations actually become less visible as they become more informationally efficient. We have literally spent decades looking for loud, messy aliens. But a truly mature, advanced intelligence, they wouldn't act like that at all. They would naturally get quieter.
Which leads perfectly into Section 4, Phase 3, Informational Integration.
So what happens when a civilization survives that noisy pressure phase and hits Step 3, Integration? Well, everything changes. They transition from wasting massive amounts of energy to building hyper-efficient, incredibly quiet systems. They use high information compression, meaning their communication is so dense with data, it just looks like random background static to us. They might even go through substrate migration. That's just a fancy way of saying they shrink their massive technology down to microscopic or even quantum levels. The final result? Near zero waste heat. They completely stop leaking energy.
And this brings us to an absolutely crucial rule from Brown's research. Advanced survivability increases as unintentional detectability decreases. Just think about that for a second. To survive long-term, a civilization practically has to become perfectly efficient. And when they finally stop leaking wasted energy in stray radio waves, they basically become invisible. They aren't hiding from us on purpose, guys. They're just perfectly integrated.
Up next is Section 5, Validation and Falsification Rules.
Now, how do astronomers actually test this in the real world? Well, we validate this hypothesis by totally changing how we search. Instead of looking for loud radio beacons, our validation test should look for signs of extreme signal compression, unusually low waste heat, or even communication methods that don't spray radiation into space. On the flip side, what are the falsification parameters? How do we prove this wrong? We'd prove it wrong if we actually discovered a massive, ancient, billion-year-old empire out there that is somehow still super wasteful, incredibly loud, and actively expanding in a messy way.
Finally, Section 6, our own silent future.
Let's bring these real-world implications right back down to Earth and look at our own history. In the past, humanity used broad, leaky analog radio waves, literally booming our old television signals out into deep space. Today, we've mostly moved to directed, networked digital communications. We are already getting quieter. And our future? It's heading straight for encrypted, hyper-compressed, low-waste fiber optics. Humanity is already following the exact THD curve. We're actively moving away from a loud, leaky past and racing toward a highly compressed, silent future.
Which leaves us with one incredibly profound question to wrap things up. Are we actually alone in the universe, or are we just foolishly looking for a loud past inside a quiet, perfectly integrated future? This completely reframes the entire Fermi Paradox. The universe isn't empty at all, it's just highly efficient. Well, we really hope this explainer sparked your curiosity about Kevin L. Brown's Triune Harmonic Dynamics. Until next time, keep looking up and keep asking the big questions.